Hello, Year 10. We're back with another myimaths question. This one we have equations of tangents. We need to find the equation of the tangent to the curves at the given points. Let's look at two of these. I'm going to look at number 2 and I believe number 4. So let's start with number 2. Okay. So we're looking for the gradient of the tangent. We need three things. We need the gradient of the tangent. We need the coordinate where the tangent is located. If we have the gradient and the coordinate, we can then find the equation of the line. Okay, we need these three things. Let's start for the gradient. To find the gradient, we need the gradient function. So, in previous lessons, we bring down the 2, multiplied by 4 to get the 8, and we subtract 1 from the exponent. That gives us 8x. Take away 5. Because the exponent is 1 here, it drops off. So we have 8x minus 5. The gradient we're looking for in this question is at x equals 2. So, what is it when x equals 2? Let's see what the gradient is. When x equals 2, we simply sub in 2 into the gradient function. So we have 8 times 2 minus 5. Who can tell me what 8 times 2 minus 5 is? That's right. It is 11. Okay? Now that we have the gradient, we need a coordinate on the tangent line. Well, the easiest coordinate to get is the one that's on the curve itself. To get that coordinate, we need to substitute x equals 2 into the function itself. This function generates coordinates. This function generates gradients. Let's use this one so that we can generate the coordinate. Subbing in x equals 2, we have 4 times 2 squared minus 5 times 2. Remember, exponents first. So 2 squared is 4. 4 times 4 is 16. Subtract, 5 times 2 is 10. 16 minus 10 equals 6. This is the y-coordinate for our point at x equals 2. So our coordinate is the coordinate 2, 6. The last step is to actually get the equation itself. For the equation, we have a gradient, it's 11, and we have a coordinate, it's 2, 6. Now we need to use this equation, the equation of a line. For the equation, we have our y value of 6. We have our x value, which is here, of 2. And we have our gradient, which is 11. Using this information, we can find the point at which the line crosses the y-axis, the y-intercept. That's what C is. Rearranging, we get C equals minus 16. Let's take away 22 from 6 and we get minus 16. So, the overall equation of the line is y equals 11x minus 16. That is the solution to our problem. Let's go back. That was for question number 2. Let's move on to question number 4 now. Okay? For question 4, let's have a look. So, question 4 is a very similar process. We must find the gradient of the tangent line, and we must find a coordinate on the tangent line. For the gradient, recall that if you have 12 over x, we can't differentiate in this format. We need to bring the x up into the numerator. To do that, we use the rules of indices. The result is 12x to the power of minus 1. Now we do our same gradient formula as before. We bring down the minus 1. That's minus 1 times 12 times x to the power of minus 1 subtract 1. So the result is minus 12x to the power of minus 2. Be careful with your negatives. Let's simplify that so it's easier to work with. Let's bring it back down. So we have minus 12 over x to the power of positive 2. This is our gradient function. We're going to find the gradient at x equals minus 2. Let's substitute minus 2 into our function. Minus 2 squared is 4. So minus 12 divided by 4 is minus 3. That's right. So minus 3 is the gradient of our tangent line. Now we need a coordinate on the tangent line. For the coordinate, we need to substitute x equals minus 2 into which one? Do we substitute it into this one, the gradient function, or do we substitute it into the original function? The original function. This generates coordinates. So we substitute 12 divided by minus 2. That result is minus 6. So the y-coordinate, or the coordinate in general, is minus 2 for x, minus 6 for y. Okay, little mistake there. That should be minus 6 here. For the equation we use y equals mx plus c. Just like last question, we substitute our values in. Minus 6 for y, minus 3 for the gradient, and minus 2 for the x value. Solving and rearranging for c gives us minus 6 equals 6 plus c. Bring the 6 to the other side. Be careful here. These do not cancel. We are subtracting 6. We are subtracting 6 from both sides, and we get c equals minus 12. In the end, our overall equation is y equals minus 3x minus 12. Minus 12. So, I've shown you question 2 and question 4 of the homework. I hope this helps you, and go back and try it again, okay? Here are all the answers for the other two. Goodbye.